Hi everyone, I'm Srinath. I work at NVIDIA and I'm here today to talk about. Oh, wait. And I'm here today to talk about the new or recent Vulkan video extensions and some of the developments in the developer ecosystem space related to Vulkan video. And I'm a member of the video TSG as well, so I'm effectively presenting this on the TSG's behalf. So today I'm going to be providing a brief introduction to the video extensions, how they are structured and in what phases they were introduced. I'm going to be covering the new extensions or the ones that we worked on and released in 2024 and the ones that we have in progress in 2025. Then I'll be talking about the ecosystem part or the tools and utilities in the developer ecosystem, which have seen updates related to Vulkan Video. And I'll conclude by briefly talking about the roadmap for 2025. So, okay, the video TSG was formed in 2018 with the purpose of bringing the video compression and decompression aspects to Vulkan. So, extend Vulkan to cover those areas in order to have use cases which mix video and and graphics or compute with low overheads and with the same performance as Vulkan. And so in December 2022, we added H264 and H265 decode sitting on top of a decode core, which would allow supporting more decode codecs in the future, and a video core, which can then be used to add video encode functionality. And almost a year later, we added video encode support for H264 and H265 on top of a video encode core, which would allow extending it to more encode codecs. Then in February 24, we released AV1 decode. And in November 2024, now we added AV1 encode and quantization maps. So quantization maps is the first of the advanced encoder features that we have on our roadmap. And we're currently working on VP9 decode and intra refresh for video encode. So in this presentation, I'm going to be talking about AV1 encode, quantization maps, intra refresh, and VP9 decode. And this slide doesn't have the maintenance extensions that we also have for video, but I'll be talking about one of those. All right, so the new extensions are, as I said, the ones that we worked on in 24 and released them, and some of the ones that we have worked in progress in 2025. And these extensions are based on the TSG prioritizing what features are required based on feedback from our customers and from the community. So feedback is really important for us, and we appreciate the feedback for any new features that people would be interested in. So the first in the list is AV1 encode. So AV1 is a royalty-free codec, and it's now gaining prominence because of adoption mainly by YouTube. So AV1, the AV1 encode extension allows Vulkan to access the AV1 encode hardware blocks that various IHVs are coming up with. And well, this is the picture that we currently or we had before November 2024, where we had H264 and H265 already out and released. And actually, when we were working on H264 and 5, AV1 was just slowly coming up. And once we had these codecs out, we switched our focus to AV1 encode, and we finally were able to release it in November 24. So I've linked to the blog post for the announcement there, which has all the details about that. Okay, now quantization maps. Okay, if you look at the scene that's there here from the perspective of a video encoder, and you have to fit this within a limited bit budget, you can see that there are certain regions which are flat or which have less detail, like the background with the sky and the clouds, and some regions with more details. And the video encoder may decide to give a very low quality to the background so that it saves bits for preserving the details in the region with the complex information. And that seems like a good idea, but it turns out that it doesn't quite work as well in practice, because video encoders divide the frame into blocks, and with each block you have a quantity known as a quantizer, which controls its quality. A higher quantizer reduces the quality and vice versa. So if you assign very low quality or very high quantizers to the regions which are flat, which have low detail, and you reconstruct them in the decoding process, then it looks really bad because you can see the blocks as they are. So quantization maps allow offsetting that or alleviating that to a certain extent. And that's done by having a quantization map like I have one here. So this is a very specific kind of a quantization map, now a quantization delta map, where each element is a delta quantizer. So a delta quantizer controls the delta that you apply for the quantizer for each block or group of blocks, and highly negative values bring the effective quantizer down for a block and thereby improve its quality. And that can be traded off by giving the complex regions higher quantizers by specifying positive numbers in the quantization delta map. And that leads to an effect like what you see. But I mean, you can see that some of the details that were there earlier in the complex regions have been sort of washed out. But this is an extreme example. It just serves to show what you can do with quantization maps. Okay, now video maintenance too has a bunch of features. I'm going to be talking about just one of them today, which is applicable for video decoding. Now, if you look at how the video decoding API is structured, it's based on the representation of data in the bit stream. So you have some headers at the start, which talk about the parameters that apply to the entire stream, or they may talk about, I mean, they may refer to pictures, they may talk about the parameters that apply to many pictures within the bit stream. So you have those headers at the start and then the data for each picture in the bit stream. And in Vulkan Video, we put the headers in a video session parameters object, which is then provided when you start a video coding scope within the command buffer, and the video commands, the video decode or encode commands, they go into the video coding scope. So they automatically get the information from the headers and the decoding continues like that. So this is all fine for, I mean, most bit streams, but there are many bit streams still out there where the headers are repeated at frequent intervals within the bit stream. And if you want to make that work along with this model, then it gets tricky because you have to then create new video session parameters objects at frequent intervals in order to specify those headers again. And that can be an overhead because of the overhead associated with creating and destroying these objects. So video maintenance too brings in a convenience known as inline, video maintenance too, yeah, brings in a convenience known as inline session parameters there, where you can specify one or more headers inline. So you don't have to put it in the video session parameters object necessarily. You can pass it directly in the video command. And you can actually take that a step further and completely avoid using a video session parameters object and pass in all headers directly for each video decode operation. Okay, now with inter-refresh, I'm coming to the first of the extensions that we have in progress. So inter-refresh is really useful for low latency scenarios like video conferencing or consumption of OTT content, and it's a tool for error resiliency. So, okay, first a primer on video compression. So if you take two consecutive frames, which in this case look identical, but they really aren't, there's a small difference there. Video encoders make use of a technique known as interprediction, where they exploit the similarity in time or the temporal redundancy that's there between consecutive frames in the sequence. They make use of that to achieve high levels of compression. So if you have frame n plus 1 can be compressed greatly. Okay? And I mean, this works when you have the stream coming over a network with over a channel with less noise. If you pass the same stream over a network with a lot of noise, you can end up losing a chunk of the data there. And well, in the previous slide, I had divided into 3 regions, and this is why I basically wanted to show that you can have one entire region lost due to noise in the channel. And if you end up losing that, then the next frame that you decode, you also end up losing a chunk of the information there because, well, the data that it was referring to is no longer available. And the same problem can happen for frames later, n plus 2 and so on, if they have some of the same patterns in the sequence. And so what you need is a way to break the propagation of errors. So you have propagation of information, which is what interprediction depends on, but then that also has a propagation of errors, and you need a way to break that pattern. So one of the easiest ways to do this is to introduce a frame which acts as a boundary. And that frame is coded by what is known as intra prediction. So that frame doesn't refer to anything else. It's compressed using the data within the frame itself. So you can do that, but an intra frame is very expensive in terms of the bits, and that can lead to problems when decoding. So instead of having one entire frame that is intra-coded, the idea behind intra-refresh is to break up that intraness. So rather than having one frame which is intra, break the intra portions across frames. So intra-refresh is basically where you split up the intraness across a sequence of consecutive frames. You have consecutive regions which are intra-coded. They don't depend on anything else. So they act as barriers for propagation of information. And they refresh the content. So now if you have a stream coded with intra refresh and you send it over the same channel as before, you can still end up losing a chunk of information as before. But for frame n+1, because the bottom part happened to be intra coded, it's preserved. And so frame n+2 and so on will not suffer from decoding errors. And this happened in sequence. So for example, frame n+1, the middle region was also intra-predicted. In frame n-1, the top region was intra-predicted. So you have these waves of intra-prediction, which make up intra-refresh. Okay, and the last extension that I have today is VP9 decode. So VP9 decode is really popular because of YouTube, and IHVs already have VP9 decoder blocks in their hardware. So it simply made sense for us to add an extension for supporting VP9 decode. And so what we have right now is H264, H265, and AV1 decode support already out. And now with the addition of VP9 decode, we'll be completing the set of contemporary video codecs. All right, now I'm going to be talking about the ecosystem side, the tools or utilities that have seen updates related to video. And this is also something that was driven by feedback from developers. So it would be interesting to see, I mean, if people have feedback on what other tools and utilities can benefit from video support, we would like to hear about that. So the first is, of course, validation layers, which are critical for getting the usage of the Vulkan API right. There's one point about validation layers that's important to mention here is that it only validates the Vulkan API usage. And there's a big chunk of the video extensions that's separate from the Vulkan API itself, which is codec parameters, or what are known as STD parameters when it comes to video. And the validation layers do not validate the codec parameters. So what can happen is that you can have an application where the Vulkan API usage is all correct when you enable the validation layers, but you still get errors because the codec parameters are invalid. And yeah, I mean, the video TSG is aware that this is a problem, and we have thought about some ways to tackle it, but we don't really have a good solution for it because of mainly 2 points. So the first is that designing a codec parameter validation layer is complex simply because of the ways the codec parameters interact with each other, that they're very complex interactions. So you would have to practically bring in the entire codec into the validation layer, implement every clause in it in order to make the codec parameter validation layer useful for all scenarios. And the second part is that codec parameter validation is a bit different from Vulkan API validation. So for Vulkan API validation, you would enable it for debugging, and then disable during production. But for codec validation, you can have, for the video decoder, you can have different streams coming at different points with different parameters. You could have, for the encode side, the parameters changing at runtime that you have to control for video encoding. So the codec parameter validator has to be enabled all the time, even at runtime. So, I mean, because of these 2 points and a few other things, we don't really have a concrete plan for addressing codec parameter validation. So we currently require that applications know the codec rules and follow them to the best of their abilities. All right. So Vulkan profiles, again, as everybody here knows. They are a way of expressing the use case that applications are interested in by listing the properties or capabilities that make up that use case, put that in a JSON schema, and then feed it to various tools and look for whether implementations support that combination. So the update related to Vulkan profiles is that Vulkan profiles now support video properties and video capabilities. So if you consider an example of, say, looking for an implementation that is capable of decoding H264 420 8-bit content, and where the decoder output allocation also supports transfers, the block that I have here is something that you would put in a profile to look for whether the implementation supports it. On the Vulkan toolset, I'm just going to be talking about Vulkan Info today. Vulkan Info earlier was already capable of showing you which video extensions are available. And that's now been extended to actually print more information about the video extensions themselves. So with minus show video props, you can see all the information that's there here. The important point is that this information here and the one that you saw in the Vulkan profiles slide, that's all driven by a common framework. So what the video TSG is looking for is feedback on whether there are certain use cases that people want to see, which can be addressed by profiles, and whether that can also naturally help have more capabilities or better information out of Vulkan Info for developers. And finally, I'm talking about the Vulkan video samples. So the primary purpose of them is to, of course, demonstrate how the video extensions are to be used. So we're aiming to have all the extensions that we have released covered by the sample applications. They have modular code. So of course, they are represented by C++ classes. So you can take them and use them in your application. And yes, the current way it's structured is that it requires you to have knowledge of the codec in order to use it correctly. And we have some additions planned for the sample applications. So we are, of course, going to add support for the extensions as and then they come along. But one other thing that we have planned is for video encode. The Vulkan API already has a way for the drivers to report, depending on the use case, what a good list of settings is, because different encoding implementations have different requirements. So there are some default settings that work for one implementation and not so well for the others. So the Vulkan API can give you recommended settings if you tell it what use case you're aiming for. And we are aiming to make that available in the sample applications so that right from the start, you have good settings that you can use for encoding. Okay, and in conclusion, the roadmap that we have for 2025 is, of course, to finish working on VP9 decoder and intra-refresh and release them to the public. And there are a few more extensions that I can't really talk about, but in general, the idea behind all the extensions is now that we have a foundation for Vulkan Video, we are trying to build on that to make Vulkan Video more feature-rich and bring more and more features for our developers and users. And we also have improvements lined up in the sample application code. We always will keep improving sample application code because we know that there are areas where we can improve on. Conformance tests can be improved, and improving conformance tests helps IHVs bring users higher quality drivers. And for the tools, we are looking for what more we can do in improving the tooling support for our users. So any feedback related to this is also appreciated. And this is the second last slide that I have. I've linked to the presentations on the Vulkan video that were covered by my colleague at NVIDIA, Tony Zlatinsky, in 23 and 24. So you can look at these for sort of an overview of the video extensions themselves, which I did not cover in the presentation today. I've also linked to the Vulkan Docs issue page. If you have any feedback or any bugs that you would like the video TSG to look at, please comment on the issues page. And finally, I have provided a link to the Vulkan events page, which is there because the video TSG is planning a webinar to cover some of the things that I spoke about here in a lot more detail. So we intend to go into the usage for various extensions that we covered and maybe some caveats or best practices for those extensions. So please register if you are interested. So please look out for whenever the announcement happens, and if you're interested, please register. And that's all I have. Thank you.
Hello there. Thank you. Do you have an idea which vendors are likely to support the encoder intra refresh extension? And is that going to be on current GPUs, or does that require silicon updates?
No, we expect that to not require any updates because for the most part, intra refresh is a feature that's already supported by vendor specific APIs. So, NVIDIA and AMD is planning to have support for it. I don't know if I can say anything more about that, but yeah, I mean, that's the plan for now. Yeah.
Any other questions? Okay, if we thank the
Thank
speaker
you.
again, thanks very much.